Hello friends, welcome to lesson 3.1. In this whole chapter 3, we're going to be talking about rational functions. So to start us off today, we're going to introduce what a rational function is. A rational function is written in the form P over Q, where P and Q are polynomials. So basically, a rational function is a polynomial over a polynomial. And if you remember from chapter 2, we talked about polynomials. A polynomial is a function that has positive whole number exponents and real coefficients. That's what makes up a polynomial. So if we look right here at example A, we look at the exponents and think, are the exponents positive whole numbers? So this exponent's a 1, that's a positive whole number. That exponent's a 1, that's a positive whole number. Check. So far it's looking like this is a polynomial over a polynomial, which would make it a rational function. So then we check the coefficients. All the coefficients should be real numbers, meaning we should not be dealing with any imaginary numbers this chapter. So real numbers, check, 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 check. All of these coefficients are real. There's no i's here, no imaginary numbers. So we can say, yes, this is a rational. Now if I come over here at B, I check my exponents. They should be positive whole numbers. And I notice very quickly a problem right here with square root of x. You may remember that square root of, whoa, that zoomed in real fast. Square root of x can be written as x to the 1/2. Same thing. Well, if I write that as x to the 1/2, then we see that that is not a positive whole number exponent. So we can say right away that the numerator is not a polynomial. Therefore, this is not a rational. No. If it's not a polynomial over a polynomial, it is not a rational. So hopefully that gives you a little bit of an idea of what a rational function is, how we can find it. So for what we're going to be doing for the next 3 lessons, 3.1, 2, and 3, is all about graphing rational functions. The graphs of rational functions look pretty funky. They look pretty weird. And the hardest part of graphing them is there are a lot of rules to memorize. So what we're going to do in today's lesson is we're going to talk about 5 of the rules that you need to memorize for graphing rational functions. When we get to 3.3, we'll introduce the 2 advanced rules. And those are the last 2 rules you need to know. So what I'm going to do today is I'm going to highlight all of my rules in purple. So then that way, as I go through my notes, it is really easy to see. All the purple stuff is the rules that I need to memorize. So we'll start off today with our first rule, which is domain. This is rule number 1. Now, if we remember from when we've talked about domain, which we've talked about since the beginning of class, domain, you look at even roots, have to be positive, and you look at denominators cannot equal 0. Well, we just showed in example 1 that roots is not going to happen in this chapter. If there's a root in it, it's not a polynomial, which means it's not a rational. So we don't need to worry about roots in chapter 3. We're not going to have them. So for our domain, the only rule we need to remember is that the denominator cannot be 0. So let's practice that in example 2. I'm going to look right here at A. First, you'll notice for all 3 of these, I don't care what the numerator is right now. The numerator is actually its own rule, and we're not there yet. All we care about is finding the domain, and the domain in this chapter comes only from the denominator. So we're going to look at each of the denominators in this problem and say this denominator cannot equal 0 and solve for it, and then write our domain from there. Now, if I look at this denominator, x squared minus 9, I notice very quickly that I can factor that as x minus 3x plus 3. So for my domain, I say those denominators cannot be 0. Solve that out, and I get x cannot be 3, and x cannot be negative 3. So my domain needs to list all numbers except for 3 and negative 3. And if you remember clear back from chapter 1, we wrote that as negative infinity up to negative 3 with a parenthesis, meaning I'm not going to include it, union from negative 3 to positive 3, so everything between negative 3 and 3 works. Don't include 3, so we're going to do a parenthesis, and then union 3 to infinity. And this is one way of saying I could plug in any of these numbers into this equation and get an answer. So basically the only two numbers I can't plug into this equation are negative 3, which is not included because it's in parentheses, and positive 3, which is not included because it's in parentheses. So this is the domain. This is the list of all the numbers that work in this problem. So let's look at B. Once again, we need to say our denominator cannot equal 0. If we look at this one, x squared plus 9, this is not difference of squares, so I cannot factor this. So I'm just going to say that denominator cannot equal 0 and see what happens. And I notice right here, I'm trying to square root of a negative, which is imaginary, and we already said we don't have imaginary this chapter. So because there is nothing, we'll write it down, there is nothing that makes the denominator equal 0. There's nothing that makes the denominator equal 0. Only imaginary things are going to make the denominator equal 0. So then that way our domain is everything, negative infinity to infinity. Basically saying I can take any number my heart desires, plug it into this equation, and I'm going to get an answer from it. Now if we look at C, remember we already mentioned the numerator doesn't matter in this problem because we are just practicing our domain rule, and domain is just the denominator. So if I look at C, C has the same denominator as A, which means it's going to have the same domain as A. Because the denominators are the same, it's going to have the same domain. So that is our first video for this lesson and our first rule. In the next video, we'll talk about a couple more of our rules that you'll need to work on memorizing. So in summary, our first rule is domains are where the denominator cannot equal 0. Come back for the next video to learn more of our rules.